In this video, we're going to introduce and cover the concept of percent yield, which is a very practical application of the synthesis of compounds and quantifying it using stoichiometry. So we're going to start with just an analogy at first. So let's say you're taking a test. So right here we have a nice, beautiful multiple choice bubble test. And let's say on this test there are, just because it's numbers here, 87 questions. And each one is worth 1 point. And you take this test, who knows what it's on, and let's say you get 71 correct. And you want to know how you did. What's your score? What's your grade? So the way you would calculate your grade is essentially you would figure out how many questions you got correct, 71, that's what you got. You would divide it by however many total questions, the maximum you could have gotten, which was 87, and you'd multiply that times 100 to get your percentage. So 71 divided by 87 times 100 would give you about 81.6%. So you know that on this test you got a low B. Percent yield is based on the exact same concept, but instead of how many questions we got right and questions total there are, we're going to be referring to the amount of compound you could have obtained versus the amount of compound you got versus the maximum amount you could have obtained to figure out what's called the percent yield. So there's going to be 3 flashcards you need to make with vocab words for this video, either on cram.com, or if you're a Quizlet fan, you can do them on Quizlet, that's fine, but you need to make flashcards for each of these 3 terms. 1, percent yield. Number 2, theoretical yield. And number 3, actual yield. And we'll go over each of those over the course of this video. So let's look at a real practical example. You have a headache. You go into the cupboard and you grab some Tylenol. Okay? Tylenol is actually just a brand name. The actual chemical in Tylenol is this compound called acetaminophen. Acetaminophen. Tylenol is just the brand name, that the company that sells it. And the creation of Tylenol occurs by the following reaction. You take a compound called p-aminophenol, you react it with acetic anhydride, and you produce acetaminophen. Remember, this is essentially our Tylenol. And you make acetic acid. What I've written here in orange, these MW stands for the molecular weight. That's the same thing as the molar mass that you get from the periodic table. But instead of making you calculate those, I just gave them to you up front. So the molar mass is 109.1 for p-aminophenol, 102 for acetic anhydride, and 151 for acetaminophen. So we can actually do this in the lab. It's actually a pretty straightforward synthesis. So let's say you were conducting this lab, and you used 0.150 grams of p-aminophenol and 0.1782 grams of acetic anhydride. How much acetaminophen, Tylenol, can you produce if the reaction goes to completion? So this is a phrase to recognize, okay? Goes to completion, that means it's going all the way, meaning everything works properly. All the molecules react as they're supposed to. Now, that does not happen in all reactions, but we need to figure out what this is in order to figure out what's called the theoretical yield, and we'll get there in just a second. So, this is a limiting reactant problem. How do I know this is a limiting reactant problem? I'm given the mass of both reactants, which should be review. I have the mass of both reactants. So in order to figure out how much compound is produced, I first need to figure out my limiting reactant. So, to do that, I start with the mass of both compounds. So 0.150 grams, I'm just going to write PA for p-aminophenol. The molar mass of it is 109.1 grams per 1 mole of p-aminophenol. And I need to convert it to mass of product, or moles of product. And the ratio here, there's 1 mole for 1 mole. All of these are 1s essentially. So the mole ratio is just 1 to 1. So 1 mole of PA, I'm going to write 1 mole of Tylenol, essentially, acetaminophen. Okay, so if I go ahead and do that calculation, 0.150 grams divided by 109, I'm going to get 0.00137 moles of Tylenol. Let's go ahead and do the same thing now with the other compound, the other reactant, 0.1782 grams of acetic anhydride. I'm just going to abbreviate AA. So now I'm dealing with this, the acetic anhydride. So, same thing. I have to figure out how many moles of product I could make. Now I'm using this compound, so I'm going to use 102 grams of acetic anhydride for 1 mole. And for 1 mole of acetic anhydride from the mole ratio, I'm still going to get 1 mole of Tylenol. This is all review. What we've done so far is not new. This is material that we've covered already with limiting reactants. And if I do that math, I'm going to get 0.0017 moles of Tylenol. So based on this information, what is my limiting reactant? My limiting reactant in this case is the p-aminophenol, the PA, because the amount of product here is less than the amount of product here. So that means this is the maximum amount of Tylenol that I can produce in moles. But I want to figure out how many grams that is. So let's just drop this down. I want to convert this into grams. So this is just a simple moles to grams, one-step conversion using the molar mass. 0.00137 moles of Tylenol. The molar mass of Tylenol here is 151.2 grams per 1 mole. So if I do that, the mass that I'm going to get is 0.207 grams of Tylenol. So what this is telling me is if I reacted this amount of p-aminophenol and this amount of acetic anhydride together, the maximum amount of Tylenol that I could get would be 0.207 grams. There's a vocab term for this, okay? This is what is called your theoretical yield. So this is a flashcard you need to make. A theoretical yield is the maximum amount of product that could be made if the reaction went to completion. Meaning if it went all the way and there were no hiccups, every molecule reacted. The maximum amount of product is your theoretical. Just think about it, the word theoretical means, in theory, if everything was perfect, the maximum amount you could make. Okay? Now part B says, if you conducted this reaction, let's say you did this in the lab, and you only obtain 0.190 grams, what is your percent yield? So, to calculate your percent yield, it's just like what we did with your test before. In the test before, we took the amount that you got, which is just going to be called your actual, the amount of material you actually got, divided by the maximum, which is the theoretical. It's the same idea, you're just calculating a percentage. So the percent yield is how much you actually got when you conducted the lab, divided by how much you could have theoretically gotten, the maximum total, times 100. So in this case, if we plug in our values, that would be the actual yield, 0.190 grams, that's what you got when you did the lab, divided by the theoretical. How much could we have gotten? 0.207 grams times 100. So our percent yield, if we did the math, is about 91.8%. Okay. So we made a flashcard for theoretical yield. Okay. What about actual yield? The actual yield is how much you actually got, the amount of compound that was actually made when you did the lab. And the percent yield, this is essentially like the efficiency of the reaction. Like how well did it work? It kind of worked like a 91.8%. 91.8% of the molecules actually reacted, which is actually surprisingly high. So things that you need to walk away with before we do another problem. When you're calculating percent yield, you need to know two things. You need to know your actual and your theoretical in order to calculate the percent yield. The theoretical you get from determining the limiting reactant. Okay? The actual is just based from the lab, what you got. So we'll do a lab this week where you actually calculate your percent yield by conducting a synthesis, not of Tylenol, but of a different compound. So let's go ahead and do another reaction together. The compound used to produce nylon is called adipic acid, H2C6H2O2 and is produced according to the following reaction between cyclohexane and O2. So here's a reaction. Okay, I'm getting familiar with it. I'm going to read part A. If you react 25 grams of cyclohexane with 500 grams of oxygen, how much adipic acid can be produced? Okay, so stop and think. Before you approach the problem, think about what you're solving for. I'm solving for how much adipic acid I can make. What am I given? I'm given 2 masses. 2 masses, so that's a key. I got to figure out what's limiting. I have to do that first. One thing I want to point out in a problem, anytime a formula is listed after a compound, that's the formula of the compound. So adipic acid, the formula is H2C6H8O2. Cyclohexane, that's the formula. So let's go ahead and calculate the limiting reactant. You should be able to do this first, so go ahead and give it a shot. Okay, so I have 25.0 grams of cyclohexane, C6H12. So I need to convert that to moles of adipic acid. So I need the molar mass of C6H12. So if I got the molar mass of that, it should be 84 grams of C6H12 per 1 mole of C6H12. And I got to convert that to moles of adipic acid. So let's look at the coefficients. It's 2 to 2. So 2 moles to 2 moles. So if I go ahead and do the math, I'm going to get 25 divided by 84, essentially, which is going to give me 0.297, 298 if I round it up. Excuse me, I wrote grams, but in reality that is moles of adipic. And with the other compound, 500.0 grams of O2. Well, oxygen is 32 grams of O2 for 1 mole of O2. And then from the ratios, it's 5 to 2. So I'm going to say 5 moles of O2, 2 moles of adipic acid. So this is going to be 500 divided by 32. Minus 2 divided by 5. It's about 6.25. Okay, so that number is way, way bigger than 0.298. So my limiting reactant is going to be my cyclohexane. This is my limiting. Which means this is the maximum amount of product that can be made. How much adipic acid can be produced? 0.298 moles. But we usually want to convert to things in grams. You don't have to do this every time. I want to emphasize that. But as I look ahead, I see the next problem involves grams of adipic acid. So I might as well convert this to grams first. So 1 mole of adipic acid. So here's the formula. So I need the molar mass of this. So the molar mass of that is 112 grams. So if I do the math, that's going to be equal to about 33.4 grams of adipic acid. So that's the maximum amount that can be produced. Okay, so quick check. What is that called, the maximum amount? It is your theoretical yield. This is how much you could produce if everything happened correctly. Now the next problem says if you obtain 33.5 grams, what was the percent yield? So there's some buzzwords here to watch out for. If you obtain, you're doing this lab, 33.5. So if you actually did it, this is what you got. This is your actual yield. So to calculate your percent yield, oops, it's a little messy. Your percent yield is equal to actual over theoretical times 100. So in this case, it would be 33.5. Excuse me, there's a small typo here. It should have been 23.5. Sorry, again, this was a typo. This should have said 23.5. That's on me, my bad. 23.5 over 33.4 times 100. So 23.5 divided by 33.4 times 100 is about 70.4%. So that is essentially the efficiency of the reaction. Cool. So again, things to walk away with. You need to know these three vocabulary words. Percent yield, that's essentially your efficiency. The theoretical is the maximum amount of compound you can make from the limiting reactants. And the actual yield is the amount of material you actually got. The formula you need to know for calculating percent yield is pretty straightforward. Just think of it conceptually like a test. Your percent, it's how much you actually got over how much the maximum you could have gotten times 100. Otherwise, we just got to get some practice together.